Alright, time for another DraftPhysics.com video presentation. So this is on the subject of the free momentum type experiments. I would argue that there is some substantial indication that this is a phenomenon created by springs. It's not really about elastic or inelastic, it's about superelastic. And that's should be in some way addressed as a fact, as a subject, a potential fact, by these people who choose to opine on the subject in ways that are not very specific. Again, in 2 years I've asked one of these opponents to draw a lever and explain how it's possible that it doesn't conserve the momentum. They sort of have to explain where the momentum actually goes. Alright, so I was thinking of a way of proving the case is with the Newton's cradle. Now you know that if I do the simple experiment just banging the same mass into the same mass, I'll just perfectly transfer the mv to the mv. Now the idea of momentum is that in these uneven transfers, if I could do them with a Newton's cradle, that all I'm really going to do is transfer a big M and a small v and convert it into a big V and a small m, and it has to equal the same amount in total. So if the m gets smaller and the v gets bigger, or you can just keep messing with those numbers and it always has to equal the same thing. Alright, so in a Newton's cradle, so their theory is as I go progressively larger, okay, so I make one object large, and I keep this one the same size. Alright, and I put the energy in, that somehow it's not a reflection that goes back, that all the energy actually, substantial amount of energy, well actually more energy than it started with, momentum goes into this object and this other one reflects back. So we get the idea if we put 100 in the case of twice the size, okay, we get 133 out here, and we get 33 going this way. So this way isn't a reflection of the energy. It's clearly something else is going on. And we could take that all the way, let me get rid of this, and I'll draw it lower. Okay, so we can go all the way up to where I have now made the mass so large that it is barely going to move. And the idea is it will absorb, say I put 100 in, it will absorb in this direction 199, and it will reflect 99. So I have this, this is really the perfect free energy relationship. So have a 1 mass against maybe a 10 mass, and you'll get this incredible increase, a doubling essentially of your momentum. So I'll have 199 momentums going this way, and I'll have 99 going that way. Now I'd say quite logically you can tell what you have, and if this was in a closed vessel, okay, you could argue that you're going to turn this way, okay, and that's what you started with, this way, because the other two will cancel out in terms of a turning force. So the fact that you can turn and cancel doesn't mean that it's not energy. And obviously if I let it into space, these are both real things in the space now, and I have a total of 300 momentums now flying in space. So I start with 100, I now have 300. So I've gotten 200 for free. Now I would argue that momentum says that this reflection is a consequence of the fact that this hasn't absorbed anything. It's only absorbed 1. So I would say that Newton and I and Descartes would say, no, you've only absorbed 1% of the energy this way. It's barely moving. And the rest reflected. So you just do 99 plus 1, and you have your original momentum. You've conserved your momentum. Alright, so I was thinking of ways you could test this. Now obviously the simplest way, in my opinion, is to, yes, use a spring to push the objects and then say which one compresses the spring back to this original condition? Do any of these scenarios compress the spring back to its original condition? All right. Well, anyway, so the idea I had was, if we understood this as a Newton's cradle, and you're really just saying that what you're ideally, you want to make a brick wall out of this, and then you'll get everything back, theoretically, right? That's an ideal spring. So we probably don't have any of those, but regardless, we're talking about getting back all that you can, okay? All that's possible to get back. And, the only way I could expect to get everything back is the wall has to not move. If the wall moves and I throw a rubber ball at it, I'm not going to get back as much. So the more the wall yields to the ball being thrown at it, the less I get as a reflection. So to me it seems obvious it is a reflection. It's the energy that went in and it's just going back in the opposite direction. It's just turned around. It hasn't done anything else. Alright, so let's say I make this 10 mass that doesn't move. So it's too heavy to move with the energy coming in. And since I started going this way, I guess I have to continue that way. So I'm going to put 100 in, and I'm going to hit the 10, and I'm going to get my 100 back. All right. Their argument is that there's two momentums in this. Okay, that actually has 200 momentum. Now I would argue if I did this on a Newton's cradle, there's absolutely no way. It basically disconnects any idea. So Professor Lewin made this argument, and he said, you throw the rubber ball at the wall, the ball comes back, and there's two momentums in the wall. And he makes it a secret, but I mean, if you go ask him, well, how can that be? The wall didn't move. He's going to say the whole Earth moved. No, the problem here is I'm disconnected from the whole Earth entirely. All I have is this little string. Now the string can't do this and can't do that, right? The only way it can put pressure on the rack is it actually the object has to move. The object has to go this way and put tension on the string in that direction. There's no way for this 10 mass to put tension on the string in the direction. It can't put two momentums into the entire rack. You just can't do it. Can't do it with that string unless it moves. It has to move to be able to move the rack. It has to move in the direction and pull on this thing here. This string has to get pulled in that direction. If it's not pulled in that direction, it's not going anywhere. And obviously you could put the whole thing on a scale and say that the whole thing, if you're going to say, well, the weight, the momentum gets converted into up and down motion. So the the 200 momentums is going down. Well, then you can just weigh the whole table, right? Put it on a scale ahead of time, see if it weighs more. It's not going to weigh anymore. Alright, so to me it pretty much defeats the argument that there's any real motion in here. And I think it's already defeated by just the idea that you can understand I can just put enough masses in the way, and it'll take way too long for any signal to go traveling all these distances to ever get to the Earth and tell the Earth to move. The Earth never going to even know this thing was hit. Frankly, the string is never even going to know it. And in some respects, that's demonstrated by, when they shoot bullets through, and stuff, you can see that the strings are the last thing to know anything happened. And sometimes it just fractures bits right off of you can actually break the weld on the ball by hitting it fast enough. It's only a string. How could a string, break off a piece of the metal? Well, it's because all the action is right here. It never, none of the pressure ever got up the string, never got to any part of the frame, never got anywhere. It didn't get past the first atoms of the plastic, and the plastic just said, I'm not going. Nothing could move the speed that the object was moving, and it all just said break because I'm not going anywhere. Alright, so I'm just saying logically this is what they're demanding you to believe happens. Now we know that this doesn't happen, and with a regular Newton's cradle, and so this extra energy thing doesn't happen. I don't put 100 momentums in and get 200 going this way, and then 200 comes crashing back into 99, and I got a 300 crash. I never get more action than this 100 in the Newton's cradle. I can't put a swing in with momentum, and I can't get the two objects to move with 300 momentum. Can't happen. Doesn't happen. They should show it if they think it happens. Okay, but yeah, there's no evidence that happens. And so again, this is about springs. And if you say, well, what could it be about springs that are the problem? Obviously, we're back to quick releases and launching devices, and the difference between hitting something, with a piece of plastic, all right, and pushing something with a spring. So, I mean, springs are a little tricky, right? If you try to push a spring, they coil funny, they do all kinds of things, so you have to create mechanisms to make it easier for you to push the spring the same amount each time. And that's a little complicated. Remember, it's also complicated, like how do you release it? Once you have it compressed, you have to have a release mechanism that somehow gets out of the way really quickly, because the spring can go really fast. So you have to have something that doesn't just let it roll over an edge or create like in this case where the little piece breaks right off. This piece will break right off. If I hit this hard enough, fast enough, a little piece here welded to this piece of metal will snap right off. Just it snaps right off. Okay, so the point is this is a lot of energy, and you're saying you're stopping it with a little piece of matter, and you're going to create a lot of little pieces here that might break off or bend or twist, and it's not going to be as perfect as you think, so you need it to happen really quick. So you got to use the leverage or some other mechanism to make sure it goes really, really fast. But banging it doesn't seem like a great idea. Anyway, so you could argue that this is all a phenomenon of bad launch devices, where the spring isn't making good contact, or it's throwing the plunger at the thing, and then the plunger hits and it reflects back, and then it gets into more pressure from the spring, and it hits back again. So it's a bunch of reflections happening. And you can't push something that way, because once you start pushing it, then it's starting to move away from you, and you can't catch up to it again. So the energy never catches up. And you end up having a spring that pops out and wobbles after the event, because it's indicating I still have the energy. That's why I'm wobbling, is because I still have it. You didn't get it all. So we haven't looked for any of that, because we can't see it in most of the videos. What's the condition of the spring after it's pushed or hit? The simple argument too, I mean, it's a simple argument. Somebody should be able to acknowledge hitting is different than pushing. Okay, I mean, I shouldn't have to make these arguments. Is that this should be a thing everybody's sort of aware of, that pushing and hitting are different things. And one of them, the push, is going to be much more consistent and capable of getting all the energy in, where the hit is going to be, it's going to be a problem. It's going to be vibrations. You don't want vibrations, because they're consuming your energy. That's energy going in the wrong direction. That's more loss. Hitting creates losses. Pushing creates less losses. Simple enough argument. All right. Again, taken to its extreme, as I've pointed out before, if you really believe this 200 thing, that somehow the object actually has collected twice as much momentum in this direction, that's possible. I put 100 in, and I get almost 100 out. Okay, almost. 200 out. I've gotten free 100. As I pointed out, if I made a spaceship and did this, and I just coat one side with a reflective material, and I coat the other side with an absorption material, I'm only going to absorb 100, but where I create reflections, I'm going to absorb 200 in this direction. So this side of my ship's going to go 200, this side's only going to go 100 from the same energy coming in from both sides. So obviously I could create an infinite motor and just throw something in space with a reflective side and an absorbent side, and I have every expectation that the reflective side is going to make 200 momentums, double my energy, and the absorbent side isn't. It's only going to collect 1, because it's not going to reflect anything. And that I could just pretty much make an engine. It'll keep getting heavy because I'll keep collecting crap, but I could just scrape the crap off and throw it into space, so that doesn't matter. It's easy enough to get rid of. But yeah, it'll go faster and faster and faster and faster, because every single time a piece of energy from the universe hits one side, I'll get twice the momentum that I'll get when a piece of energy hits the other side. To me, these are evidence of a paradox. The experiment has flaws in it. It doesn't go consistently to all different realms that you can test it in. And that's another thing, like Physics Michael made a whole video talking about, the scientific method again in testing and how to examine one single experiment. But what he didn't say anything about is the fact that what you really want to do is confirm from a lot of different ways. You want to show it takes 4 times the fuel to go twice as fast. 4 times the F to go twice as fast. You want to show that. You want to show how this kinetic energy theory is consistent in all areas, when I can't even get it to survive springs and no springs. Frankly, they can't show me the experiment where there's no springs and this extra momentum thing happens. They can't show me the earth moving when I throw the tennis ball against the brick wall. Now they should be at least able to show something, right? Some indication that the building knows I threw a tennis ball at it. That the rest of the building knows it happened. They don't have that. Let's see what else. Anything else that needs to be added? There's a big difference between reflections and absorptions. Because I could make a machine. I mean, Tesla did this a lot. Where you just bang into something constantly, bang, bang, bang. So you have to add energy. You have to keep adding energy. It's not like a pendulum. You can just let it swing. So you add a little hammer, you bang, you lift the hammer, you bang, and it's all energy going in. So it's real energy in the sense that there was no reflection. So you bang the energy in, and you're forcing it in, and then you can create an oscillation over time. So if you do it at the right frequency for the piece of metal you're hitting, you can get the energy to go in and vibrate the metal inside. So it is moving. It's just the movement's really subtle inside the material, and it doesn't start to wobble the whole bridge until after a day or two. That kind of thing. It's a real thing. Oscillators and resonant frequencies, and the fact that you just keep adding the energy. But again, the key component to that is there's no reflection. Even if Tesla believed in mv squared, right? Wouldn't Tesla have figured out that, I want a reflection, because then I get twice as much energy into the machine? Yeah, no, he didn't think so. All right. So, I guess I could do one more just for the sake of, it's more direct to the argument, I suppose, and just makes the point that, okay, if this was real, this mv squared thing, it has real, this extra doubling of the momentum. If this is a real phenomenon, then when we heard of like bomb technology where, you would actually layer your bomb with little objects, okay, and then you'd have a layer of bigger twice, actually you'd want them big enough to take advantage of that full 2, but just by doubling them, okay, you do get 33%, which is pretty big. So just with a doubling of the velocity, the doubling of the weight, you get 33%. Now if you triple the weight, I don't know what you get. You would kind of argue that it gets 66%. I'd have to go four times the weight. So I start to get pretty heavy. But so let's just go with the 33%. So let's just say we double the size of the bits. Okay. So I put little tiny BBs, and I put bigger BBs, and I put bigger BBs, and I put bigger BBs. Well, didn't really make them bigger enough. Okay, and so I layer it, and then I can guarantee that when the bomb pressure, that I'm going to explode, the explosive is here. So just imagine this layer on the opposite side, dot, 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 and then another wall. Okay, you can just understand that I can take a small amount of explosive, and I can increase the pressure it can create on the surface, merely because I'm going to create more and more momentum. I'm going to keep having more momentum moving in this direction. So I'll get, 33% here, and then another 33% increase here, and then another 33% increase here, and another 33% increase here. And I think that probably comes out to something like 3 times. So I'll have 3 times, 3x. Let me just make sure of that. That might be an exaggeration. This would be 133. This would be like 175. This would be 2 something or other. So yeah, it's almost 3. So I have 3x the pressure. So I can take 1,000 pounds of pressure here, and I can turn it into 3,000 pounds of pressure here by layering the bomb in a specific way. Now, anybody think that's really true? I mean, have they ever heard about this being a real thing and making anything happen or anything move? I mean, wouldn't I do this with every single thing? Every movement that I try to capitalize on, a water wheel, anything? Wouldn't I try to maximize this effect and try to take advantage of it? Because frankly, any reflections here are just going to be to your advantage, right? So let's just understand that reverse motion is going to be pushing in this direction. So I should have pointed that out, right? I'm getting the extra 33 this way, and I'm also getting a free 33 the other way. So just understand, inside an explosion, that means I'm pushing this wall with 33. So I'm pushing this wall with 133, and I'm pushing this wall with 33, which can only be to my advantage. And anything that reflects is just going to hit the other wall. So I really am just creating a lot of free energy. I'm getting free energy out of the explosion. I only have to seed it with a tiny explosion, and I can make a big giant explosion merely by taking advantage of the fact that I have all this extra energy. It's going to keep bouncing back and forth, back and forth, back and forth, and just keep expanding the explosion. Just saying, it doesn't fit. They're claiming, and just let's recognize these are not direct experiments showing us KE. They're not showing us a generator. They're not showing us watts. They're not showing us some sort of real heat thing. They're not showing us any real collection of the energy. They're just stating it exists as a mathematical statement. It doesn't really exist as an actual practical statement. Now, I would argue that clearly in the experiments with the springs, okay, the momentum thing isn't working. But the argument is it's only not working because the spring isn't working. You're not getting all the energy into the lighter objects for whatever reason. And that if you really tested the experiment, that is, you went through, the one mass against the 2 mass, and the 1 mass against the 3 mass, and then the 1 mass against the 4 mass. And their observations are saying, I keep increasing the amount of momentum in this direction. Well, then try to push that object back into the spring and see if it compresses it. Which one will put the spring back in its original condition? And I would argue they're not going to. It's not going to happen. They're all not going to be able to put the spring back together again. And that'll be evidence that the problem is in the launching, and that it's cheating the truth, because the spring isn't being allowed by some flaw in the design of the experiment to produce the energy. But again, this whole reflection argument, I'm just saying, I think the Newton's cradle proves it, that if you suspend a ball from a steel wire or something, and it doesn't actually physically move, it can't possibly transfer its energy to the structure. It can't move the earth. And the fact is that the energy is just reflected. All you have is the reflected energy. The stuff going forward, okay, any energy going in the forward direction has to be subtracted from the reflection. Anytime the wall yields to me throwing the ball at it, I'm going to get less back. All right. So enough of a video. Blah, 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 blah. All drawings. Very nice.